1.2 volume. So we're going to focus on um, three different shapes here. Okay, we have a cylinder. We use this formula here, pi r squared h, to find the volume. Okay, we have a rectangular prism, and we're going to use length with height to find the volume, and then triangular prism, half the base times the height, and then times the length. So basically like how wide this is. So again, like what we see for actually all three of these is essentially what we're doing is the volume is going to be like area of the base times whatever the height is. So area of the circle, which is pi r squared, and then times whatever the height is, right? So this would be pi r squared, and then we'd have to multiply by height. The rectangle would be, let's go length width, which is the area of the rectangle, but then we have to multiply it by the height. And triangular prism, same thing. We're going to go area of the triangle if is half the base times the height, and then the actual height of, like, let's just call it L, like length, but the actual height of the object. Okay, so the general formula is half the base times the height. Okay, the base of a prism is one of the two congruent and parallel polygon sides. So the base here would be a circle. Okay, the base here would be a rectangle, and obviously this is a rectangular prism. That's how it gets its name. The base here is a triangle. Again, that's how it gets its name, triangular prism. Prisms are named by their base. Okay, and just please note, to apply a volume formula, all the measures must be in common units. So you may run into a question where one thing is in centimeters, one thing is in meters, and then we're going to have to convert. Okay, example 1, volume of a prism. So a ramp is in the shape of a triangular prism. Determine the amount of concrete needed to make the ramp. So we have a triangle right here. I'm going to make it brighter. There we go. Okay, we have a triangle. These are going to be at 90 degrees. Okay, that's like an assumption that we can make. So, for example, if we're going to do the area of a triangular prism, or I can just put area because it's the only, volume. Okay, let's go area of the base, okay, times the height. So the area of the base is going to be half the base times the height, which is going to be, the base is going to be 6, the height is going to be 1. So half of 6 times 1. Now, let's just call this the length because, so in area of the base times, let's call this L for length, okay? And this is going to be base, this is going to be height. It doesn't matter, those three are interchangeable. I'm just kind of trying to go with the formula on the first page and not double use one of the variables. So half the base times the height times, and then it's going to be 10. Okay, so 6 times 1 times 10 is 60, half of 60 is 30. So they would require 30 meters cubed. Okay, volume's 3D, so we measure in cubic meters. So therefore, 30 meters cubed of cement or concrete is needed. Okay, volume of a cylinder. Example 2. A soup can is in the shape of a cylinder. Okay, the soup can hold 500 milliliters of soup. How tall is the soup can? Okay, so we're looking for the height here. And what we're given here is the diameter. So that's kind of useless. We would need the radius, which is the diameter divided by 2. So 5 over 2 is 2.5. Okay, so please note 1 milliliter, which is what this is measured in, is 1 centimeter squared. Oh, this should be cubed, sorry. 1 centimeter cubed. And this is actually like in real life. So if you took like a pop can and you measured it and you got something centimeter squared, like for example, a lot of pop cans are, I think it's like 355 milliliters, just as an example. Well, you should get that approximately for if you took a ruler and measured. Okay, so for the soup can, we have volume equals pi r squared h. but we know volume, it's 500. We know pi, it's 3.14. We know the radius, it's 2.5 squared. And then we don't know the height, right? How tall is the soup can? That's kind of what we're trying to solve for. So let's go ahead, and this right here, this portion that I underlined, let's go ahead and multiply those. So we're going to have 500 equals 19.625H. Okay, divide both sides by 19.625. And we're going to get 25.47. Maybe 48, let's round up. Okay, so then we can say, therefore, the height of the soup can is 25.48 centimeters. Now, example 3, we're going to touch on the volume of a composite figure. Okay, determine the volume to 2 decimal places of concrete needed to construct the staircase below. So here's the thing. We can divide these into different components. You can go straight down. You might see it straight across as well. I'm going to go down, but you're going to get the same answer, so not to worry. Okay, and this is 1.5, and then this is going to be 1.5 as well because of the dash. Okay, and now 1, 2, 3, 4, 5. So there are 5 sections here. What I'm going to do is I'm going to take the 1.5 and I'm going to divide it into the 5 sections. That means each of these sections is 0.3, 0.3, 0.3, 0.3, 0.3. Now, going up, this would be the 0.3, but this is going to be 0.3 and 0.3 again. So this is going to be 0.6 that we need to use. I'm going to make this a little darker so we can see it. Okay, and then this one right here, 3, 3, and 3. So this would be 0.9. 3, 3, 3, 3, this would be 1.2. And then this one, of course, would be the full 1.5. So we're going to have to calculate all of these separately. Let's call this 1, 2, 3, 4, and 5. This is going to have 5 different calculations, and then we're going to need to add them after. Okay, all of these, I keep putting area, I really do mean volume. All of these here have, there we go, volume of number 1, volume of number 2, volume of number 3. Okay, all of these volumes have the same formula, length times width times height. So the volume of number 1 is 0.3 times 0.3, right, times 1. So we get 0.09. Now the volume number 2, we have 0.3 times 0.6 times 1, which is 0.18. Okay, number 3, 0.3 times 0.9 times 1, which is 0.27. Okay, and let's do volume of 4, volume of 5. Okay, length with height as well. So we're going to get 0.3 times 1.2 times 1, and we're going to get 0.3 times 1.5 times 1. And let's see what we get. So 0.36 and then 0.45. 0.36 and 0.45. Okay, all of these are measured in meters cubed. So if you want to add those, it's good form. Now we can do, again, I'm putting area, so volume, the total volume is going to be 0.09 plus 0.18 plus 0.27 plus 0.36 plus 0.45. Okay, and you can go ahead and put that in your calculator. And we get 1.35. So 1.35 meters cubed. So therefore, it will take 1.35 meters cubed of concrete for the stairs.